Welcome to our tutorial on how to do stoichiometry problems when we are at STP. So you'll usually need to look for this keyword here. So whenever we have a reaction that's occurring at STP, at least one of our values, we're going to be using our simple conversion factor that we've used. So remember, STP is going to always be 0 degrees Celsius and 1 atmosphere. So if you're given any questions where you're given a pressure that's a different number of atmospheres or a temperature that's anything but 0 degrees Celsius, you know you're not going to be using STP. So let's go ahead and read through this question here. So in the reaction, 2CO, so carbon monoxide, plus oxygen, they react to yield carbon dioxide. The question's asking how many liters of oxygen are required to react completely with 6.7 liters of carbon monoxide at STP to make CO2. Now, I've seen some people kind of get confused with this extra part when it says like to make CO2 here. It's just describing the reaction. So the only parts that we really need to key in on are our starting units, okay, which we're given 6.7 liters of carbon monoxide, okay? And the question's asking how many liters of oxygen are required. So, how many liters of oxygen are required to react completely? So, we always start with our given value. So here, we've got our, if we map out our process here, so we're always starting on the green side, right? So, since we know we're at STP, again, the question said STP right here, so we know that when we're talking about volume, at least for our starting substance, it's always going to be this pathway right here. So if we look, we don't have to plug into any equations. If it was not at STP, we would need to use this, but it is. So fortunately, we can just go ahead and plug into this reaction, or plug into this step, I should say. So then from here, we're going to go to moles, as always. Our first conversion is always moles. And then we need to go to moles of our second substance here. So then from there, okay, our question was asking how many liters of oxygen. So from there, we know it's either going to be here, here, or here if it's in liters. But it's at STP, so we know it's going to be this one. Okay, so nice and easy. I'm not actually even going to flip back to it because it's nice and easy to remember. From here to here, our conversion factor is going to be 1 mole to 22.4 liters of gas. So same thing over here. And again, this is only at STP. So the conversion factor is going to be 1 mole equals 22.4 liters there. Okay, so now if we look at this here, okay, so our starting point was 6.7 liters of carbon monoxide, so CO. We need to write both our unit and our substance. If we're not doing that, you're going to most likely make mistakes. So we need to make sure that we have both the unit and the substance. Okay, so since it's one of our printed parts here, we know that we can just plug in. So anything that's printed on our roadmap, we can just plug that straight into a sequence, just right across. So if we have any time where we're using one of these equations that we added on there, we're not going to be able to just plug straight in. Okay, so we've got liters of CO up here, so we need liters of CO down here. So our conversion factor was 1 mole equals 22.4 liters of gas. So we know that this is going to be 1 mole of CO equals 22.4 liters of CO. Now, we can't just jump straight from liters of CO to moles of our other substance, which is oxygen, because we have to get to moles of our first substance first. So this next step is going to be our mole bridge. So we've got moles of CO on the bottom, okay, and we're trying to get to oxygen. So we need moles of oxygen up top, okay? So we look to our balanced equation here. So we've got 2 moles of CO, that's the coefficient of 2. We've got 1 mole of oxygen. Okay, so now, since we can just plug straight into our sequence here, we're going to just put moles of O2 on the bottom. And we're actually just going to use this exact same conversion factor because it's the same right here. So we're going to have 1 mole of O2 and then 22.4 liters of O2. And that's it. So now we go ahead and just plug everything into our calculator. Again, putting everything in parentheses on top there. Okay, and I'm going to try and angle this so it's a little easier to see. Okay, so we've got 6.7 times 1 times 1, so we could just do times 22.4. Okay, and I recommend getting an answer for the top, especially if you're struggling here. So then we divide by everything that's on the bottom. So 22.4 times 2, which would technically be times 1, but we don't need to include that 1 because it's just going to be 1. So there we go. That gives us 3.35, and that ending unit there is whatever we have last. So 3.35 liters of O2. Okay. So that's for how to do a mole conversion at STP. Pretty straightforward. And now we're going to move into molarity and using the ideal gas law.